In today's video, we're going to build a simple application using the microservices architecture and .NET Aspire, which is going to power our services. We'll discuss the pros and cons of microservices, the trade-offs that we're going to make along the way, and why .NET Aspire is the right choice when building microservices in .NET, and all of the good things it does for you that you're not even aware of. So let me first walk you through the services that we're going to introduce as part of our microservices system. Let me color them so we can differentiate between them, and let me assign some names to them. This is going to be the notes service, and we're also going to have the tags service. So the idea here is that our application users can store some notes inside of the node service, and the node service is going to depend on the tag service to generate a set of tags for the nodes. We're going to use separate databases for these services, so let me add them here. So we're going to have two databases, but in order to keep things simple, I will use the same database server to host both of the databases. And as I said, we're going to orchestrate everything together using .NET Aspire so that we can nicely run our system using .NET Aspire and Docker. When it comes to the benefits of having microservices, one of the biggest ones is having independent deployability between your two services. The node service and this respective database is independently deployable from the tag service. This means you can evolve them separately, you get failure isolation out of the box. When one of the services goes down, the other one is unaffected, although they can't communicate with each other. We're also going to implement synchronous communication between these services to start out, and we're going to discuss the pros and cons of this, and I'll give you some ideas of how we're going to evolve this going forward in one of the future videos in this series. Now, obviously, the example here is somewhat simplified. These services aren't doing all too much, but let's try to discuss why we would want to have a separate tag service and not have both of them deployed together as just one monolith. One reason could be having a different rate of change between these services. The node service can be pretty stable, whereas the tag service can be quickly evolving. For example, we're going to start with a manual implementation of tagging the content of the nodes, and we're going to evolve this into using AI and a large language model to generate the tags. Another reason is having failure isolation. If the large language model that we are depending on goes down, only the tag service will not be operational. The node service can continue working as expected, granted that we implement the communication between them with a fallback in case the service is down. And another argument could be security. For example, the tag service doesn't really need any personally identifiable information to be able to generate the tags for a given node. So that's a couple of reasons off the top of my head. Now let's jump into Visual Studio and let me show you how we're going to build this. So as promised, we're going to start literally from scratch. I have a blank Visual Studio solution and I want to introduce a new project. I'll choose ASP.NET Core Web API. I'll call it Notes API. I'll use .NET 9, which is the latest version at the time of recording this video, and I want to enlist this in .NET Aspire orchestration. Let's click Create, and this is going to scaffold our solution, the app host, and the service defaults project. If I open up the app host, you can see our one API project is nicely configured and is going to be up and running when we start the application. Now I'm going to get rid of all of the boilerplate in the API until I'm left with only this in the program file, and then let's go ahead and add another project to our solution. It's going to be an ASP.NET Core Web API, and this one I'm going to call the Tags API. I'll click Next. We're going to also enlist this in .NET Aspire orchestration, and then I'll click Create. I'll also remove the boilerplate from the Tags API until we are left with the same content in the program file as the Notes API. The app host has been updated to also include the other project, and one more improvement I want to make right off the bat is turning on central package management. So there are a couple of ways you can do this. One of the built-in ways is through an extension, which is called the .NET Upgrade Assistant. So once you have this installed in your Visual Studio, you can right-click on any project and find the Upgrade button, and one of the upgrade options is Central Package Management. What this is going to do is create a directory packages props file that is going to contain the NuGet package versions, and inside of the project file themselves, we only reference the NuGet packages that we need. So I'm going to let the Upgrade Assistant complete this. You'll see that this completed successfully, so I can close it down. Everything is going to build if I build the solution, and if I open up the project file, you can see that we are now just having a package reference without the package version inside, and this is true for all of our projects. Now, the directory packages props isn't available in your solution right away, but it's there in the same folder, so you can include it explicitly by right-clicking, going add, and then choosing existing item and finding the file. And once you do that, you can examine the contents of this file, and it looks something like this, containing the package versions, where just the references are inside of your project. So I'm going to close everything down but the app host, and let's try updating our NuGet packages. I'll go into the package manager, updates, and you can see I have one package I need to update. In the directory packages props, this package is available with the version of 9.7.0, and if I go ahead and click update and go back to the directory packages props, you can see that the version has been updated. So the NuGet package manager in Visual Studio works okay with central package management. Now the next thing is going to be introducing our database. I'm going to right click dependencies, add a .NET Aspire package, and I want to look for PostgreSQL because I want to be using Postgres. So I'll install Aspire hosting Postgres. Let's add that. And now in the app host, I can define my database instance. I'll close this down and I should be able to say builder, add Postgres, give it a name. I'll expose a port on my host where I can connect to this database, and I'll just use the default port, which is 5432. Then we're going to say with data volume, so it'll be persist any data, and we're going to say with lifetime and choose container lifetime persistent so that the container survives through application restarts. So this is going to be our Postgres instance. And then we're going to add our databases. So let's first create the notes database. I'll say Postgres, then I can say add database, and let's call this Notely Notes. This is the made up name of my application. If you want to get rid of these warnings that this is a typo, you can add this to the user dictionary. I'll choose the solution level so that anywhere Notely appears is going to be recognized as an existing word. And let's add the tags database. I'll say Postgres, add database, and let's call this Notely tags. So as I said, I'm using the same database server, but I'm hosting different databases on it, which are going to physically separate the data between our two services. So let's reference the notes database in the notes API. I'll also wait for it to start. And we're going to reference the tags database in the tags API. So let's add with reference tags database and wait for the tags database to become available. Now I did say that the notes API will need to communicate with the tags API, and we're going to do this synchronously using HTTP. So we're going to also add a reference to the tags API from the notes API. So I'll say with reference tags API, and let's also wait for the tags API to become healthy in order to start the notes API properly. Lastly, because I want the notes API to be available from my local system on a fixed endpoint, I'm going to expose port 5001 so that I don't have to look up the Aspire assigned port, which is somewhat random. So now we have our two services ready. Our Postgres instance is also taken care of along with our two databases, and we have all the correct references in place. Aspire is also going to take care of a bunch of best practices like configuring open telemetry, health checks, service discovery, and also taking care of resilience when sending requests using the HTTP client. Now, if you want to learn more about this, I have a bunch of videos about .NET Aspire that cover these topics, and I'm going to leave them in the description of this video. Now, let's start with one of our APIs. Let's say the Notes API, and here I want to implement our first entity and also define the database context and expose some functionality through the API. So I'll create a new folder in the Notes API project, and let's call this data, and let's define our first entity, which is just going to be a class that I'm going to call note, and I'll drop in some properties inside. We're going to need an identifier, and let's also assign a title, the content of the note, and we'll store when it was created and updated. If we want to be more explicit with the naming, we can say that both of these values contain the UTC time, which is recommended when working with datetime objects. The next thing we'll need is an EF Core database context, and I'm going to add an Aspire package because it takes care of some useful things when it comes to using Postgres with EF Core. The package is Aspire PostgreSQL Entity Framework Core Postgres. Let me install the latest version, and I also want to look for EF Core tooling so that I can generate my migration. So I want to install Microsoft Entity Framework Core tools. So let me add that. And going back to my application, I'll be able to add my database context. So let's add a new class. I'll call this the notes DB context. We're going to add a constructor accepting a DB context options of the notes DB context. Let's call this options. We have to implement the DB context base class and pass in the argument. Then we're going to define our database set of notes. I'm just going to define it as a simple property with a getter and a setter. And then let's override the onModel creating method so that we can configure our entity. I'm going to drop in the implementation to save us some time. And I'm not doing anything special here, just defining what is required or not. If you want something to not be required, for example, when the node was updated, we can make this field nullable and explicitly say that it's not required in our EF core configuration. The next thing we need is our database migration. I'll use the package manager console, and I want to change the startup project to Nodes API and also the default project to Nodes API. And I'll say add migration, create database. And I want to output this to the data/migrations folder. Now this is going to give me an exception because I don't have my database context configured. So how we can fix this is going to our program file, and you have two ways of how you can configure this. There's the add PostgreSQL database context, which is an extension on the application builder, and we can specify our nodes DB context, but note that by default, this will use DB context pooling. If you don't want to use this, there's always the default approach. You can say add DB context, specify your context name, and inside of it, you can say use PostgreSQL, and we just have to specify our connection string. I'll say builder configuration get connection string, and the connection string name is notely notes. This is the name of our database that we configured in the Aspire app host. Now the thing with the Aspire library is that it extends the default behavior by adding retries, health checks, logging, and telemetry to your database context. So you can add that after configuring it with dependency injection by saying enrich DB context and then specifying the nodes database context. And then let's say that we want to apply the EF migrations while we are in the development environment. I'll create a service scope. I'll use this scope to resolve my database context, and then we can say DB context database migrate. And I'm going to repeat the same thing for the tags API, but I'll fast forward to once I have the complete implementation just to save us some time because it's more of the same. If you're following along yourself, go ahead and do that before continuing with the video. So now I have the same implementation in place in the tags API. We have the respective tags DB context with one entity inside represented by our tag. We also added an index to speed up any queries using the node ID, and the tag itself is pretty simple. It just contains the name of the tag, some color that we are assigning to it, which we can use for rendering this on the UI, and the node ID so that we know which node this is associated with. So now we should be able to generate our database migrations. So let me retry the same operation as before, and this time we get our migration with one table. Now let's also generate the same for the tags API, and I'll just rerun the same command and switch the default project. And after this, I should have my database migrations ready. So you can see our tags and nodes table will be created in our databases. So let's go ahead and switch the startup project to the Notely app host and start the application. So you can see our services are starting up. We have our Postgres instance, which is running two databases, the nodes and the tags databases. And then we have our two APIs, which are going to start, run the database migrations. If I take a look at the nodes API and the references that we have here, here's the connection string, which points to our nodes database. And it also has an environment variable pointing to the tags API. So if you go here, you can see we have an address for the tags API using HTTPS, as well as HTTP if we don't want to use HTTPS. So congrats to you if you made it this far. All of this was basically adding the building blocks for our microservices system. We now have orchestration in place. We also have structured logging. We also have open telemetry, even though I don't have any traces right now. You'll be able to see this. And we also have metrics. So the next thing we need to do is to finally add some behavior to our system. So let's go ahead and create an endpoint where we can create our first node. I'm going to use a feature-based approach to organize my endpoints and use cases. And let's create a features folder. And inside of it, I'm going to add a new folder called create node. Now let's add a class inside. You can choose if you want to use one class per feature or multiple. Let's call this the create node endpoint. I'll make this internal and static, and inside of it I need to define my request delegate. So this is going to be an async method returning an iResult. Let's call this create node, and we need a couple of arguments. One is going to be the actual request object, and here we basically just need the title and the content. We're not currently associating the nodes with any user, so we can just inject the incoming request, and let's call this the request object. Then we're going to need the nodes database context and an iLogger so that we can add some information as this is executing, and I'll use the program class as the scope, and then let's define our body. So what we want to do is create a new node instance. I won't be doing any validation right now, so let's say we just set the title and the content to the values coming from our request. We're going to set when this was created to datetime UTC now. And for the ID of the node, let's use, for example, version 7 UUIDs because they are sortable and then contain a timestamp component. So now we add this to our database context and we call save changes. And then we can say return results.ok, and this implements our endpoint. Of course, this has to be a static method. Now, let's say we also want to return something. I'm going to add a response object, and this is going to contain a list of tags, which are going to be represented with the tag response. Now, don't worry too much about this for now. I'll show you how we're going to populate this, but let's instantiate our response object by saying new response, and I'm going to pass in the required info. So we have the node ID, title, node content, node created at UTC, and we're going to pass in an empty collection with the list of tags. Then we can return our created response, and the URI is going to be nodes, and then we need to be able to provide the node ID as part of the route, and let's return the response object. So this is our happy flow for now. Now let's say we want to add exception handling. In here I want to log any errors and return a problem response. This is going to be converted to a 400 bad request, and if you want to, we can be more detailed about what went wrong here. So this should work when we start the application, but we'll be missing the tags that we are somehow supposed to get from our other microservice. So let's see how we can implement this part to tie everything together. So the first thing we need is some way for our two applications to communicate. The simplest approach can be using HTTP and synchronous calls over the network. And we need some sort of contract for the requests and responses that we can send between these two services. Now, I like defining these in a separate project. So I'm going to add a new class library to the solution, and I'm going to call this notely shared. Let's create it. And in this case, I want to create a shared folder for my DTOs. Let's move this class inside, and I want to define a couple of records here. The main one being the analyze node request, which is going to represent a request that I'll send from the nodes API to the tags API. Then we'll have a respective analyze node response, and this will return a list of tag responses. So we might as well define this as a shared contract. So now in my create node endpoint, I can decide if I want to depend on this local one or the shared one. So let's say I don't want to define the same type twice. I'll add the reference for the notely shared project to my nodes API, and I'll omit the tag response here, and I'll just import the one that I defined in my shared library. So now we have our request and response objects, and we can use it to implement the communication between our two APIs. So as I said, I want to implement this synchronously using HTTP. So I'll do that by injecting the iHTTP client factory, which will allow me to generate a new HTTP client. So then let's grab our set of tags from some helper endpoint, which I'm going to call analyze node for tags, and it's going to just return the list of tags. And the arguments for this are going to be the analyze node request. We're going to define this in a moment, the HTTP client factory, and we can also add the logger if you want to add some log statements. So let's define the analyze node request. We already know what this contract looks like, so we just need to fill in the missing pieces and pass in the ID, the title, and the content. And now we have to implement our new method. So let's add a private static async task returning a list of tag responses, and let's call this analyze node for tags. So as you can see, I'm getting a solid completion here, which is going to use my HTTP client factory to create an HTTP client, send this request to the tags API. It's also going to take care of logging, exception handling. So I'm happy with this and I'll accept it. And then let's fix the couple of typos that I made. I'll change the client name to be tags API. I'll change the URI to be tags/analyze. Our response object is the analyze note response, and we have to check if this is not null and if it also contains the set of tags. If we don't get back a success status code, then we failed to analyze the node for the tags. So we're going to add a warning log, and we can just return an empty list. Now, what's missing is the HTTP client definition. We can define that in our program file by saying builder services add HTTP client, and let's call this the tags API. And here we can pass in a delegate to configure our HTTP client. And the first thing I want to do is set the base address. I'll set it to a new URI, and we can use the service discovery syntax to specify that we can either fall back to HTTPS or HTTP, and then we have to use the name for our service, which is going to be tags API. Now, this is the logical name, which is defined inside of our app host, so we called it the tags API, and this is how we can reference it in our HTTP client definition, and service discovery is going to resolve this into the correct physical address. If you recall, a moment earlier, I showed you the environment variable that gets set when we start our applications. So the create node endpoint is now complete, and now that we also have our tags returned from the tags API, we can set it as part of the response. Now let's assume that the tags might change over time as we evolve the tags API, and we don't want to store this locally in the nodes API. Now this does have some performance drawbacks, as well as the synchronous communication between these two services. We're going to discuss all of this in the upcoming videos and how you could go about solving these potential issues. So now what's missing is the implementation for the tags analyze endpoint, which should live in the tags API. So again, in order to save us some time, and because this part isn't too interesting, I'm just going to define the feature folders, the base features folder. Inside of it, I'm going to define a new feature called analyze note, and I'll drop in the implementation. If I go into the analyze note endpoint, you'll see that we are missing our contracts. So I need to reference the Notely shared library, and now this should work. And here's our implementation for the analyze note endpoint. It's very simple and brute force. We're going to take the title and the content and just compare it against some keywords. So we have work, personal, important, urgent, idea, and so on. We're going to associate our respective color with each of these. And if anywhere in the text we mention these words, we're going to add the respective tag. If we don't have any tag in the end, we're just going to use a general tag as the fallback option. Now you can imagine how we can control this behind a feature flag, where if we don't detect any tags, we can just return an empty list. We're also going to store this in the database for the tags API so that we can retrieve it in the future easily by just passing in the note ID. And we're going to return the respective response. And what's left is to register the respective endpoints. So here I'll say app map post. We're going to say tags/analyze, and I can just say analyze note endpoint and pass in the request delegate. I need to do the same in the notes API so that I don't forget this. I need to say app map post. I'll just use notes as the route, and then create note endpoint and pass in the create note as the respective delegate. Now I can also move this into an extension method that's going to live in my feature folders. Nonetheless, we now have one complete flow in our application, and let's go ahead and test this out and see if it works. So I prepared a request in Postman that I'm going to send to my notes API. So I'll click send, and we hit the breakpoint in the create note request delegate. So here we're going to create a note, save it to the database, and then we want to send a request to our tags API. So we're going to go into the analyze node for tags endpoint, fetch the HTTP client, and note that the base address here is still using the logical address for the tags API. It's not until we send the request that service discovery kicks in and resolves the proper physical address for this response. So you can see after I try to step over that line, I hit our next breakpoint in the analyze node endpoint. This is now our second microservice. And here we're going to analyze the node, the title and the content, and decide which tags we want to associate with this. So now you can see I have another request. This is probably because of a retry, and I don't know what the end result is going to be. But nonetheless, let's press continue, and we should get a response back in Postman, but I managed to exceed the timeout while mumbling about the implementation specifics. So now we end up in some intermediate state. Recall that our call to save changes completed, but our synchronous call to the tags API did not. And now we have the note in the system, but we don't have the tags. And this is why synchronous communication is both simple, you saw how fast this was to implement, and also problematic if the downstream service is unavailable or under some load and it's causing timeout. So I'll press continue. And let's just fix this by resending the request. I'll hit the first breakpoint, press continue, and we should get a response back that also contains the tags, and you can see that this is the case. So now we have everything working. Now let's take a look at some telemetry data. I'll go into traces, and let's take a look at this trace here, where we have a failure and a retry from our nodes API. You can see that this post request fails because of a timeout. This is because I stopped on the breakpoint to explain how this works. Now note that the actual request to the tags API completed successfully, and because it was retried, we managed to write to the tags database twice, and now we've duplicated the tags for the same node, and this is definitely something we want to avoid. Now in this case, this happened because of the resilience handlers that Aspire introduces to HTTP clients, but it's also not uncommon in microservices systems that you get network glitches and you get retry requests. So one solution for this is having idempotency on the consumer side. I can send a request ID with my request, and the tags API can detect if this is a duplicate request that it already completed. It doesn't have to produce the same side effects twice. Now, doing asynchronous communication with messaging also suffers from similar problems with repeat messages, but is not going to suffer from network glitches like we have here. Now, the successful request, which you can see here, just writes to the node database. You can see we have our insert statement into the nodes table, and we have our post request to the tags API, and then we are inserting the tags into the database of the tags API, and finally returning the response. So this is our successful span here. We can go into the structured logs and see what has been happening here, and we can also observe some metrics, let's say for the nodes API. And for example, if I take a look at the active requests, here's what I see in the graphs. So this is all available thanks to OpenTelemetry that Aspire integrates for you. I also mentioned the resilience, which you could see here with our retried request. We also get service discovery. Let me show you what this looks like. So notice the request here. We're sending it to a localhost address, even though in our code, we are sending it to a logical address for the tags API. So here's the full log. We are sending it to this URL, https://http/tags/API/tags/analyze. So this is our base address, the logical address, and then the actual URI that we want to invoke. Now, when we actually send this request, we are sending it to the localhost address, which is resolved at runtime. So this is the simplest way I could explain service discovery to you. Now, if you want to grab the source code for this video, it's going to be available on my Patreon. I'll leave the link to that in the description right below. And I'm also going to add a couple of get endpoints so that we can more easily test our two APIs. Now, in some of the future videos, I'll discuss how to solve the issues that you saw here, like idempotency, dealing with synchronous messaging, and when services are unavailable, using AI for analyzing the contents of the tags. And I think it's going to be a fun little series about building microservices applications using .NET Aspire. Let me know in the comments what you think about it. If you want to learn more about how service discovery works and how you can use it even outside of .NET Aspire, I recommend checking out this video next. Consider smashing the like button for the YouTube algorithm so this gets recommended to more .NET developers. Thanks a lot for watching, and until next time, stay awesome.